it's time to do something useful and properly automate the publication of this content to YouTube. And we'll use AI to help us get there. Everything will be locally sourced AI. No cloud services will be used for the code generation portions of this. First, we'll use a model running locally on MLX. Then we'll pivot to a similar model running on the same machine, leveraging Ollama, so we can compare results. This comparison isn't exactly apples to apples, as the models aren't 100% the same. One reason for this may be the more experimental nature of MLX compared to Ollama, which is more ready for prime time at this point. There's also the issue of AI being non-deterministic, meaning there is no single right or wrong answer, even from the same model. In preparation for this episode, the same prompts were passed to the same models, often with kind of comical results. And to make the solution usable, we'll integrate it into a working IDE. Copy paste between a terminal instance and an editor just won't be reliable. Besides, context and meaning get lost between tools like this. Ollama was chosen because the installation and setup are legitimately dead simple. MLX is simple in that it comes native on Mac OS. Install the right mix of Python libraries and you're off to the races. Ollama is more of a consumer grade installation in that the user interface manages a lot of the models and operational environment for you if you want it, and those models have been optimized for these variables. The primary use case in this video will be writing the code necessary to publish a video to YouTube and to automate the video title, description, thumbnail image, and an optional privacy setting just to control when an episode is visible so that we don't bother our subscribers when we're testing something out. Instead of cluttering up a machine that's used every day, let's instead use one of the purpose-built lab machines that we've used previously. There's no reason whatsoever we couldn't use this daily use machine I'm on right now, but AI models occupy tons of disk space, and frankly, I don't want to clutter up my daily driver. First, let's try using a model on MLX to generate the code necessary to publish a video to YouTube. Then we'll compare that output to the same question asked to Ollama and see if we can spot differences between these approaches. With that out of the way, let's dig in.
All right, we start out by using SSH to connect to our remote machine, remote but on the same network. Then we activate our Conda environment, and then we're going to start MLX, and we're going to use a couple of parameters. We're going to use the -- model parameter, which tells it the name of the model to use, and the -- host parameter, which tells it to bind to an IP address that is reachable from elsewhere. I call this local AI, but that term is sort of extended to local to my home network setup. Let's go ahead and start MLX with these parameters. Then we'll open a second tab in terminal so we can use curl command to ensure our model is usable. This just sends a really simple hello prompt to the model so we can confirm it's operational. Then we open the continue extension in VS Code, which we're using as our IDE, or integrated development environment. Bring up the configuration file for the extension, and we paste in the setup for MLX, making sure the model name and both the extension configuration and the MLX command match exactly. Lastly, we select our MLX local setup in the dropdown where we indicate which model to use, and we're off to the races. While AI is doing its thing, it would be a good time to ask you to like and subscribe for the channel. This is a lot of fanfare for what turns out to be a really inferior solution on the back end. There was a bit of a hiccup where I saved a bunch of files to the wrong location, but we'll correct for that as we go along. I want to be able to commit the solution in its entirety to GitHub to be able to show these differences to everyone. The links will be in the description. And we should be ready to start our comparison now. Let's stop MLX. Then we use the command to install Ollama fresh on this machine, just to show it's not difficult in the slightest. We go ahead and tell Ollama to pull the model that we need it to use. I've chosen Quen for this demonstration. There will be a really deep dive into the differences in model quality, reliability, and everything, but we're building things foundationally to start out with. I also need to direct Ollama to use a network port reachable from another machine, same as with MLX. With Ollama, we use an environment variable to accomplish this. And same as before, we can use curl to see Ollama respond to a simple prompt. Making sure the model matches what we use to start Ollama is very important. As we head to our IDE to update our configuration and generate an output from our second model to compare to the first. We save that file and we go to the chat window to create a new chat session. I'm going to go ahead and clear the chat history just to make sure that things are as clean as they can be. And once again, the results from this take a minute or two to finish up. Those results are a lot more comprehensive than what we got from the previous model run. I'm just cleaning up a mistake I made so we can compare outputs in just a second. If anything, this exercise proved local AI, even for a small scale thing like this, is in no way for doing anything reliable. I've talked before about how AI is a better developer, but humans will always be better engineers. This is an example of why. Were there challenges in understanding the requirements as they were given? It seems so, and things like that are where I tend to struggle a lot with AI. That is, how do I describe to AI what it is that I'm looking for? Even though this video is edited and the time is compressed, the actual time from having nothing to comparing two different working solutions on my local machine was just under 15 minutes, including time for a couple of downloads and some mistakes that needed to be corrected for. Again, this comparison isn't 100% one-to-one. In fact, it may be a bit more skewed than I originally thought, but this is good enough though. Our last step today is to compare the outputs of these models visually, just to see how different they are. And as you can see, compare is a strictly pedantic term here. It's kind of tricky because these are really two different solutions. The models have different base models they work from, which is kind of unfortunate. I kept running into technical issues and I didn't want to get too stuck in this. The text in green represents the solution I pretty much used, but I ended up rinsing the entire thing through Devin and Claude code for one of what I saw was one of the more brutal code reviews I've seen in quite a while. But the output from Devin was able to get me exactly what I was looking for. That's all there is for today. Thank you all so much for watching and subscribing and liking if you have. Take care.